Okay, so this is the beginning of the second video related to the second part of the structure of chemistry participation assignment. And I've moved on to the next slide of the Nearpod presentation. And this is also what's in our notes. It's important to remember that, especially for pure substances, all of the properties we're making such a big deal about, and those properties are, right, matter has properties. Matter has changes or undergoes changes. These are the properties that we're making a big deal about. It's important to recognize that these come about because of the arrangement of the subatomic particles in each atom. Okay, how the particles in the atom, especially the electrons, are arranged. That's what gives rise to the properties. So if the arrangement of the properties, or the arrangement of the electrons, is what causes the properties, it should make sense that if we make good enough observations about the properties, those properties will tell us something about the structure. Okay, so if the properties come about because of the structure, it should make sense that if I make good enough observations about the properties, I can learn something about the structure. And I want to show you what I mean by that. And so I'm going to go to a different page here. And so I'm going to pause the video just for a second and then come back and be on that other page. Okay, so just wanted to draw something out here for you real quickly, and you'll be able to do this before too long as well yourself, because I want you to, and I'll never ask you to memorize the periodic table, but I do want you to be familiar enough with it that you can actually sketch out a reasonable shape of it, and it's going to work like this. So in the first row of the periodic table, and you don't need to draw this yourself, we're aware that we have two elements. Okay, I've got hydrogen and helium on one, or hydrogen on one side and helium on the other side. If I go down to the next row, I've got two columns on the left side and 6 columns on the right hand side. And then if in the third row, we repeat that. And then below that, on the left-hand side, I've got the 2 columns go down to the end of the table, and on the right-hand side, I've got the 6 columns that go down to the end of the table. And then in the middle here, I've got 10 columns. And then at the bottom, I've got 14 columns. So on the left-hand side, I've got 2 columns. On the right-hand side, I've got 6 columns. In the middle here, I've got 10 columns, and then at the bottom, I've got 14 columns. So even that in and of itself is kind of interesting, right? I've got 2, then I add 4 to get 6, then I add 4 to get 10, and then I add 4 to get 14. But that's not my point here. My point is that if we make detailed enough observations, we can tell something about the structure. And remember, I made a huge deal at the beginning of the course that the reason that we have this shape in the first place is that everything in column 1 has similar properties. Everything in column 2 has similar properties. Everything in column 3 has similar properties. Everything in column 4 has similar properties. Everything in each column has similar properties. That's how they got into their place in the periodic table to begin with. Okay? And what we found out, and we've talked about this before too, is that the reason that everything in column 1 has similar properties is because its outer shell of electrons has 1 electron in it. In column 2, the reason that everything is in column 2 is because every atom in the area, every element in that column has 2 electrons in its outer shell. Now, we didn't put them there because they had 1 electron or 2 electrons or 3 electrons in their outer shell. We didn't even know about electrons and protons when we created the periodic table. We put them in their columns because of the properties that they had. It just so happened that the fact that things were in column 1 turned out to be important because everything in that column had 1 electron in the outer shell. Okay, so we figured out what column they were in based on their properties, and then we learned that because of those properties being in column 1, that we had 1 electron in the outer shell. Okay, we didn't put them there because they had 1 electron in the outer shell. We put them there because of their properties. And then we found out, oh, by the way, these things have 1 electron in their outer shell. These things have 2 electrons in their outer shell. So that's what I mean by this idea that if we make observations that are detailed enough, those observations will then turn around and tell us about the structure. Because we made the observations before we knew what the structure was. And those observations then told us what the structure was. Okay, so when we talk about pure substances, elements, we're going to talk a lot about the atomic structure, and we're going to talk a lot about the periodic table, and we're going to talk a lot about the properties of these atoms as it relates to their structure in the periodic table. Okay, so I'm going to go back to the presentation now. Just remember, you'll be able to draw this at some point here in the near future yourself. Okay, so now I'm back in the presentation. Again, the implication is that if we make detailed enough observations about the properties, the clues in our observations will tell us what the structure is. So if we go to our graphic organizer, look under elements right here, and this is where I want us to put atomic structure, periodic table, atomic properties. And then we're also going to talk a little bit about the nuclear structure, how the protons are arranged in the nucleus with the neutrons. So put that under elements as well. Okay, then we're going to go to the next slide. And now we get away from all of the things that define matter. So everything that we've talked about so far describes matter. Now we're going to talk about what happens when matter interacts chemically, when it undergoes chemical reactions. Okay, so everything up to this point has described what the nature of matter is. Now we're going to talk about what happens when matter interacts with itself. Or you're aware that these are interactions resulting in the change of one or more substances into one or more different substances. And we're going to think that it's really important to recognize that there are energy changes that go along with this. Okay, so when I have any kind of a physical change or a chemical change, I have an energy change associated with it. Somehow energy is either absorbed by the system or it's released by the system. And not do we only need to know about the changes that occur in the types of substances that we have. We've got substances that change from one type to another type. We also need to know what happens when the energy changes in those reactions. Okay, now you don't need to know about these types of reactions yet. You may have heard of some of them, but the types of reactions we normally study include oxidation reduction reactions, precipitation reactions, acid-base reactions, and organic reactions. And so I want to put this in our graphic organizer. And this goes under the reactions right here. Okay, reactions is going to go under compounds. And then I've put the types of reactions in this third spot here, which doesn't really make sense, does it? Why would I put something in the third spot as my first thing? And the reason that I do that is because when I think about reactions, the first thing I think about is, well, what types of reactions do I have? But then I recognize that before I can ask what types of reactions I have, there are a couple of other things that I need to know about, and that's why I'm going to put those in the first two spots in the organizer. Okay, so in order to be able to study these reactions, we have to understand the system of chemical names and symbols that we use, right? I can't write out a chemical reaction, no matter what type it is, without knowing something about the symbols and the chemical names that we have. And the other thing is that I also need to know how to balance and calculate mass and amounts of products and reactants participating. And that's going to be a topic called stoichiometry. Okay, so I've written the word stoichiometry up over here. Metry meaning the measurement of, and stoich, so the measurement of stoichs. Okay, that's not really what that means. I haven't bothered to actually look up the word origin of stoichio, but it means the measurement of amounts. Okay, so we also need to know how to balance and calculate mass and molar amounts of products and reactants participating, and that's a topic called stoichiometry. So what I want in those first two spots in the graphic organizer then is, in order for me to know about the types of chemical reactions, I first need to know how to name chemicals and what their symbols are, and then I need to know how to put them together in different amounts in chemical reactions, and that's stoichiometry. Okay, so just a couple more things there, and we'll be done with this organizer. Another major component is the understanding of the nature of chemical bonding. Okay, once I decide I want to learn about how chemicals change from one form into another in chemical reactions, I need to know something about chemical bonding and the energy changes that occur when bonding occurs. And so we're going to ask, what is the nature of energy change that makes it desirable or not desirable for a bond to occur? And before I get into this, actually, I'm going to stop this video and go into a third video so that we don't run out of time here in this video. So let's pause this video, stop it, and come back to the third video at this point.